Hey there. Do you recognize this? Well, chances are, if you've been to a hospital or you've binge watched Grey's Anatomy recently, you recognize it as a heart rate monitor. Whether you knew it or not, you are actually watching a line graph form. Now, this one is called electrocardiography because it measures the electronic signal given off every time your heart beats. If we kind of examine this graph, we can actually draw an axis here where our x-axis is time, and our y-axis will be the strength of the electric signal given off by your heart. I'm just going to call it SH. In this unit, we're going to go over how to interpret a line graph and how to use it to gather information you need to solve a problem. So the target for this unit is I can create and interpret graphs to show information. Well, why do we use graphs? Well, without looking at huge sets of data, we can easily determine what the trends are, or, in other words, what the relationship is between the x and y axis. In this example, we can see the average monthly precipitation in inches over the course of time. So, January, February, March are pretty dry, and then it spikes in August here. In another graph, we're looking at a stock report from Goldman Sachs, a really big bank. We can see the trend here as the year goes on, steadily increases. Now, it's not as simple as a line graph because there's a lot of variation in the data, but we can still see a trend, and that is that, well, the company's doing pretty well. And our next graph, which is kind of a funny one, is ordering at a food restaurant. On the y-axis, we have, well, certain you are of your food choice. And on the x-axis, we have the proximity of the waiter. And it's happened to all of us, where as soon as the waiter comes to your table, well, you all of a sudden don't really know what to order anymore. This is a graph I made showing the fun level while playing the game Monopoly. Now, I always start out kind of not really wanting to play, but I get into it, and I start doing well. It's a lot of fun. I have ups and downs, but inevitably, I always go bankrupt. And that is where the amount of fun goes to ugh. And I hate everyone I'm playing with. Now that we've seen a bunch of graphs, let's take our turn in making one. We're going to graph Emma's speed at which she exercises her horse. Now, first, we have to set up our axes. So, our x-axis will be labeled with time. And the y-axis will be speed. So reading the problem up above tells us the horse walks at a constant speed for the first 10 minutes. And we'll show that by drawing a line right about 3 miles an hour for the first 10 minutes. Now, reading the problem again, the horse's speed increases over the next 7 minutes, and then it goes to a gallop. Okay, so now we have to show that our horse increases its speed over the next 7 minutes. So over the next 7 minutes, the horse increases speed to 20 miles an hour. Reading the problem again tells us that the horse gallops at a constant rate for 20 minutes. Constant rate meaning the speed is neither going up nor going down. So we can draw a flat line to show constant speed throughout the whole 20 minutes. Then the horse slows down over the next 3 minutes and walks at a constant pace for another 10 minutes. So that means our line goes all the way back down to a walk and continues to walk for another 10 minutes. That's when the ride is over. Now it's your turn. Go ahead and read the problem and select the correct graph that matches what is going on in the problem. You can click pause and we'll show the answer in just a second. Okay, so let's go over it. Jenny leaves home and drives to the beach. She stays at the beach all day and probably gets a really bad sunburn, and then drives back home. Which graph shows this example? So we're looking for a graph that shows the distance between Jenny and her house increasing at first as she goes to the beach, remaining constant while she stays at the beach, and then the distance between Jenny and her house decreases as she goes home. So if we take a look at graph A, we show the distance increases, but then it immediately decreases, showing that Jenny would have spent no time at the beach. If you look at graph C, it looks like she starts out at the beach, slowly walks home, maybe stays somewhere, gets ice cream, and then finishes the trip. That can't be it. Which leaves option B. Jenny leaves her house, stays at the beach, and then goes home. Now let's take it up a notch. Go ahead and read the problem carefully, and then sketch a graph showing the distance from Miley's house compared to time. After that, use your graph to find the total distance traveled, both to Miley's house and then back again. Go ahead and click pause, graph in your notebook, and then calculate the total distance traveled. Let's take a look how to solve this. So the first thing we're going to do is we're going to set up our graph. The first thing we do when we set up our graph is, you guessed it, set up our axes. So we have our x-axis here, and that is going to be time. Our y-axis is going to be distance from home. I labeled the y-axis in miles. So, let's read the problem. Miley and Katrina traveled 10 miles from Miley's house to the movie theater. So the first thing that we can do is show Miley and Katrina going 10 miles. So we start here at our origin, and they walked about 10 miles. Now, the reason we don't start at 10 miles is because, well, they didn't teleport. They didn't just start at the movie theater. They actually had to walk there. Because they walked, it took time. So, now that we're at the movie theater, they watched a movie. So, over the course of, let's say, 2 hours while they watched the movie, they didn't go anywhere. So that shows that our distance is going to be constant. After the movie was done, they traveled 5 miles farther to a restaurant to eat lunch. So our graph shows them walking even farther from Miley's house to the restaurant. Now, they stayed, and over a course of, I don't know how long, an hour, say, they sat in the same spot, neither decreased or increased their distance. And after lunch, they went all the way back to Miley's house. And our next task is to find the total distance. So, if we're looking at our graph, we can see that at first, Miley and Katrina traveled 10 miles to the movie theater. So, in this first section, we have an increase of 10 miles. Then, after they watched the movie, they traveled 5 miles even further. Okay. And after, they traveled a whole 15 miles back to Miley's house. So, if we add up all of our distances, we get 30 miles as the total distance that Miley and Katrina walked in a day. That's actually a really long way. And if we wanted to know just how fast they traveled, well, then we would be able to calculate the slope of each one of these lines. But we'll save that for another chapter. That's all, and thanks for watching.